Hey everybody, I am so incredibly excited. If anyone knows me, I am talking about Joe Bowler and Open Middle. Those are my two favorite things in like the whole world. And then we have Robert Kaplinski here today, who I have on autocomplete. I type his name so often. Robert, thanks for being here.
Thanks for having me. I appreciate this opportunity.
Thanks. For those of you who don't know about Open Middle, it is DOK Level 2 and DOK Level 3 math problems. It's all free and it's open source. And because it's open source, Tim, of course, put it into GeoGebra because that's Tim's, I like to call him GeoGebra Tim, and I appreciate him. He's always helped me out a lot. So, Tim, you want to talk about what you're doing?
Sure. No, totally. Thanks, Alice, for doing this. And Robert, thanks for joining us. And Chris and Victoria, thanks for joining in the fun here. So yeah, Open Middle is awesome. And, you know, in the workshops I've been doing with teachers virtually pretty much like 99% this year, it's like, you know, teachers, you know, you had the same thing over and over again, where it's like, you know what, assessing students in this remote and hybrid era is so difficult because a lot of the typical test questions we give students, it's like, well, they just, you know, in a classroom where you can have them put their calculator away and do everything here, you know what, they do it. But in remote learning, when everyone's at home and we all have this in front of us, math thing, right? It is very difficult to create some genuine assessments where the kids are truly conceptually thinking, and that at a higher level, you know? And so my question was, I'm thinking, I love everything ed tech, you know, sure, you know, my favorite's GeoGebra, but I love them all. But the point is, it's like, how can we effectively use ed tech in order to increase the DOK level of the tasks of our assessments or in-class, you know, instruction? We want to increase the DOK level, and also be able to formatively assess their work easily in a remote setting. And GeoGebra has the digital solution. Open Middle has the content solution. So you put the two together. In my opinion, it's a win-win times a scale factor of I can't count that high, you know? And Robert, could you comment on the Open Middle philosophy briefly for those who are like unfamiliar with it?
Yeah, I would say that the basic idea of an open middle problem and where the whole phrase open middle comes from is that a problem has a beginning, a middle, and end. And sometimes we say, oh, I love open-ended problems, but I think it's worth unpacking the nuances there, right? So when you have a math problem, a typical math problem, everyone starts with the same beginning, the same problem, so the beginning is closed. And if everyone arrives at the same answer, it's not an open-ended problem, it's actually a closed-ended problem. So what's really interesting, and I'm not against open-ended problems, there's value to that as well, but open-middle problems that have a closed ending are fascinating because every child may get the same answer, but it may approach it from a different way. And so then the conversation is then, well, how are these strategies related and what can we learn? Which strategies are more efficient or more visual or more this or that? And so it leads to really fun conversations in class. And I could go deep into it, but on a high level, that's what it's about.
That's awesome. And so what we're going to show you here today, we're going to chat it up live. You know, feel free to throw your comments and questions in the chats there, whether you're watching on YouTube, Facebook, or whatever group you might be in. Right there. Alice, would you go do that, please? Thank you. But basically, you know, we're going to show you how you can use GeoGebra and Open Middle together to actively engage your students in a remote setting. We're going to carry out a couple simulations live right here, have you guys all join us. Okay, and we'll have fun in doing that. So now what I'm going to do here is drop a link. It's already in the comments, but I want to first of all drop a link to Open Middle's site for you all right here. Let me do that. Okay, so this is the Open Middle site, openmiddle.com, going out there. And for all the GeoGebra Open Middle problem analogs that we've collected so far, you can get it right here. Okay, wait, where is it? There it is. Let me just drop the URL right there, so you can have it. All right. So there they are. Now, Robert, how many Open Middle problems are on the site? Was it like a few hundred, you said, or?
Yeah, I think it's probably near 600-700.
Okay. So
it's somewhat of a bell curve, and it's really heavy from 3rd grade to about Algebra 2, and it's a little bit lighter in K1, 2, and maybe like calculus, stats area.
Gotcha. So if you want to go to that, the ones that have GeoGebra link there, would you like me to? I could share my screen, Alice, or did you want to do it, or you want me to take it? Okay. So let me go ahead and just share my screen really quickly here, and we'll take you on a little journey here. So this is what you see. Okay. Now I cannot see the StreamYard, but am I showing my screen here? Okay. We're good.
Yeah.
Okay, so here it is in the open middle. This is a collection of open middle problems. We're going to start with like first grade and work our way slowly upward, just so you can get an experience of not only of what open middle is about, but how you can use a digital solution of GeoGebra to engage your students in that higher level thinking process. Okay, so I'm going to take you to the second one in here called Equality version 2 here. Okay, so you see right here, let me just hide this, right? And I can actually full screen it by hitting the little square down here. All right. So right here, all this asks us is to create a true number sentence, right? Now, how many solutions are there to this really? I mean, a lot, right? This original design was created by Steve Phelps. Steve Phelps, he is an awesome, if you're not following him on Twitter, make sure you do so. It's @MathTechCoach. But Steve Phelps created this prototype of these number tiles in GeoGebra, and where you could just drag them in and just have like, you just fill in the boxes here. So let's just go ahead and like do that, right? So you got a 4 + 2 = what, 9? I mean, a lot of ways. But Robert, what is this, kindergarten or first grade maybe? I'm not sure where it falls.
Yeah, it looks around first grade.
Yeah. So again, asking your students to literally create the problem. Again, correct me, but like that's the open middle philosophy. Or kids are actually building, they're creating. It's more of like a synthesis kind of thing, right? Versus like find the sum, lower level DOK. You know?
I think to some degree we all experience math as robotic, where you're just doing these steps that someone told you to do a million times, but not necessarily understanding it. And like, I mean, you could ask all sorts of interesting questions. Like, are there any numbers you definitely don't want to use in some spots, right? And that could lead to, well, how do you know that? Or which numbers are better to use, which are worse to use? And so you can have all sorts of conversations about the solving of the problem that maybe wouldn't make sense in a typical just addition and subtraction problem.
Exactly. And even here, through some toolbars here, so, depending on, there's ways you can actually edit some of these. Well, maybe we can represent this number, just using some sticks, you know what I mean? You can actually see the kids. We're going to talk about the digital interaction, how you can see student work in real time. But again, by literally having the students draw it out, say something like this, and then take away 3. Gosh, I have the same amount on both sides. Cha-ching, So let's see how we can actually do that, okay? If you create a GeoGebra account and you're logged into GeoGebra itself, okay, you can press this button up here called Create Class, all right? So I'm going to do that. And think of a class in GeoGebra as more of a live lesson. So we're going to call this Open Middle and GeoGebra, say take 1, right? And I'm just gonna create it from here. I'm really creating a lesson. The students, the people make up the class, right? But nobody's in yet. So here's what I need to do. I need to literally copy the link to the class right here, like so, or I can just go, I can literally get it from right here. Okay, the share icon there. Do that. I hit copy link, and then, all right, Alice, if you could take my screen out of the, can you take my screen out of the thing for a second? I'll go in here and I'll drop you the link for you, right? Actually, I'll take it out. Drop you the link. There you go, right here. Okay, so come join our class. Putting it now. There we go. Oops, I forgot to put the URL there. Silly me. Sorry. Here it is. There.
Yeah, all the time.
And for everybody who's in on the chat here in the thing here, I'll give it to my co-hosts here as well, so you can see it. All right, we have a student here already. Welcome. All right. Now I will tell you that a couple little bit of GeoGebra little tidbits here. If you manually type in your name, your work is not going to save. However, if you opt to log into GeoGebra, like if you're logged into GeoGebra and you join the class using your GeoGebra ID, your work will save and you can access it later at any time. Okay, so we have people that are trickling in. Okay, we'll give you guys a few more seconds. All right, my screen sharing, I'm not. So let me go back and share again. All right, we'll do that. And sorry, right here. Dr. B started working already, right? But see, this is the cool part about GeoGebra Classroom is that you can see at any moment in time, you can see what tasks students are working on and how many they started. Like, for example, here, this student here has started the first out of 3 tasks, and we can see what's going on. This person's on task 1, right? You see live thumbnail updates literally in real time. Okay. Now, if you scroll over here, again, we're just doing the technical side of GeoGebra here. But if you go to this little icon here, you see that this activity has 3 tasks. If you click on a single task here, like I'm doing right here, I can see everybody's work on the first problem. See right here? So those of you that are in the class, would you please make an addition sentence that is true? And would you actually show me by actually drawing those little hash marks? Just so I want to see your conceptual reasoning here. Okay.
And while they're doing that,
sure.
I'm Victoria, by the way. Sorry I came late. My internet's been acting up a little bit, but I just want to say how great I feel like this is for especially our littles. So I teach a STEM cooking class where we literally do this and we go over, different types of equality. What does it mean if we have 6 cups of sugar, if we're making large quantities of brownies? What does it mean if we have 2 sticks of butter? And we always do these types of equality problems. That way they can understand how that influences the cooking and just the makeup of the food we're going to have. Mm-hmm. So this is a great way to just show equality and also get students involved with that process. This is great. I'm like,
absolutely.
This is wonderful.
And a couple other things. No, I totally agree with you, Victoria. And a couple other things too, which Alice and I've mentioned before. But there is a pause button. Again, I don't like to use it that often. I know people love the pause button, but I know when I was in high school and other school, I always hated it when the teacher interrupted my train of thought. But there are times when we need to pause it. So at any time I could pause it, and you get this notification, hey, whatever, and so we could resume it. But another cool option, Desmos has this as well, but anonymizing the names. But here we can hide names. So if I want to have a class discussion with my first graders, I can actually, unlike Desmos, we don't have mathematician names, but here we have the student by number, but I can ask my first grade class, which students gave me a correct number sentence? What do you think? And we could actually have a live discussion right there. You see what I mean? But the possibilities here, I think, are really cool and endless. And we're starting with the first grade, but we'll definitely work our way up for sure.
So you could treat this in similar fashion to a number talk in your classroom, be just a standard sort of, let's approach this same idea from as many different perspectives as possible.
Absolutely.
I like that. That's a great idea.
I can also see this doing really well for asynchronous work, or maybe a bell ringer for students. Mm-hmm. So we're going to maybe assign anonymous responses for students, and especially because some students might not want to get all their math out there, and when they first enter the class.
Right.
But
right.
You can assign anonymous names to students. They can kind of do this number sentence thing. They can come up with responses, and then that could be an opener for discussion for math class.
Totally, like just what you said. I could take a screenshot, hide the names.
Absolutely.
Command Shift 4 on my Mac. Here's my screenshot. I'm going to put that on my bell ringer tomorrow. Analyze. What do you think?
Yeah. And just, what you
yeah.
notice, you wonder, right? Where are people doing, correct math processing? Where are some areas where we might need to adjust? And because it's the whole class, then you can come forward and as an instructor, right, you can go through and see where there might be needs to address in your classroom.
Exactly. No, that's very valid points. And so, Again, just the GeoGebra journey here. There's 3 tasks in here. It's the same GeoGebra app, just duplicated. You have 3 times here, but we can see live updates in real time. And just for teachers, some teachers were complaining before because they're like, if I want, let me show names. Say if I want to look at Robert's work, did Robert do task 1? I want to look. Oh, is his name here? Oh yeah, he's there. But teachers were fishing for student names in every task, and that's a pain in the butt. But what you can do instead, if you want to see one student's work all at once, you go right here to the class overview. Okay, the top left button there. I just click on Robert's name, and I get a quick little snapshot of how he left it as I entered it, if that makes sense.
So I would be curious to hear Robert's take on this approach using GeoGebra.
I would love to hear. Yes.
Yeah, I think that in this time of remote learning, one of the challenges is actually how do you know what your students are doing in real time? And there are some hacky ways of doing it, but this is, I think, one of the challenges is really to give, the more that you can see what they're doing in real time, the better you can give feedback in real time. So I think there's a lot of value to this, in ways that are similar to what I've also seen with Desmos. But I think what GeoGebra is really great, and which you've shown me in other times that I imagine we'll see today, is some of the visualizations of the mathematics that can happen in real time that help you understand it more than just the computation, but more by developing the visualization, you can see conceptually what is actually happening. And I think that's really powerful.
Sure. Cool. No, I love hearing that. And actually, we can keep the journey going. So we started at first grade. Let's go up a couple grades. All right. We'll still do some arithmetic here, but let me go to let's see, where was it? I think it was this one right here. So that's my GeoGebra class. And by the way, if you're a teacher, notice how I'm logged into GeoGebra. You got a little mugshot there. But your GeoGebra cloud, your storage space on GeoGebra literally is your profile, and it's right here. Okay, so if I go right there, you'll notice that I have folders, I have things in, but the last resource I have was this class that I created, right? And if I want to go back to it at any time, I can see students' work. Okay, it'll always be there. And if by the way, if I don't want students working on it outside of class, I can just pause it before the end of the day, and then I'll hit play when I get back to school the next day. Again, not to encourage control issues or anything like that, but again, I like to use the pause button sparingly for only important reasons. But GeoGebra does plan to have pacing coming along, where like I know, which Desmos I know has already. It's kind of like I want to restrict only this like this kind of thing. Maybe slide the bar here or there. It's coming, just not quite there yet. All right, but let's take a look at some more open middle here. I lost the link, so I'll just type open middle here. Come up, right there. So next, so we have a few chapters here. I want to show you something. I think here. I think it was where was it? I think the next one I wanted to show was right here. Again, this one was. I think this was next on the agenda. This one was made by Steve Phelps. Again, he is a master of everything EdTech. Anything Steve touches turns to gold, right? So, like right here, I could try this one here, all right? And if you guys want to drop it, Alice, you have the link there, right, from the Google Doc, I think, that I shared in the private chat. But again, we could try to do this and see. Well, again, some teachers have different feelings about the whole guessing and checking, right? Obviously, this is wrong. Right. Now, I personally feel that, and I'd love to hear Robert's take on this too, because I think there was a Twitter discussion on it earlier. But I personally think that something like this is useful in some circumstances, but there may be some teachers that don't want this, because like now I'm thinking, granted, I can't stop a student from taking their parent's cell phone and just doing it on the calculator, because again, remote. But at least if I can if I want to increase the level of reasoning and conceptualization, I can actually copy Steve's amazing work here, and I could just get rid of this button, right? So if that interests some teachers, because some teachers, they see GeoGebra stuff, and I get questions all the time. How do I want to get rid of this, and I want to put my own question in, and I want to, you know what it's like? It's like it's like the administration of your school shared a Google Doc with you that you want to touch, but you can't touch it because you don't have edit access. So what do you do when that happens? Well, you file, make a copy, right? Well, if you're logged into GeoGebra, look at this. You can go right here, click on those three dots, up, and you want to copy the activity. Not the book, because that's all the stuff, but the activity is that the single thing we're looking at. So check this out. I'm going to copy that activity. And just like Google does, you see the words copy of. So I'll say add some, subtract some, say from Steve Phelps. Now, this actually, GeoGebra adheres to the Creative Commons licensing, so that if I were to publish this, Steve Phelps by default, his name appears too, because he's the original creator of it. But right here, if I go here, I don't want to do any advanced GeoGebra programming. I just want that little pencil icon, which is hard to see sometimes. You click on that little thing right there. Click on it. Right. You click on Edit Applet. And if the best way to do it is right click. If you right click on that button, just uncheck Show Object. Now students won't be able to see the sum. They'll have to actually figure it out, hopefully without a calculator, but can't force stop everything. But I hit done, and there I have it. Okay, so maybe I want to do this as some kind of quick summative assessment. I don't know, but I'll hit done. And I could just literally leave it as it is, hit save and close. And now I have my own personal copy. Now the workflow here is going to improve. It brings you back to Steve's original, but if I want my version of it, you got to go back to your GeoGebra profile right here. Everything you create or copy, whatever you do, always goes on your profile. And see right here. Now I have it without the button.
Are you going to create a class?
Yeah, we don't have to create a class for every single one we do, but obviously people will still see the workflow. I'd like to create a class from a 3D version very soon. Okay, we'll do that. Right. But just wanted to show people that these open middle problems, you can differentiate quickly by copying the activity and maybe deleting a couple things and adding your own little flair, like a question or whatever. And you could do that within a matter of minutes if you really wanted to.
I like to add my Bitmoji.
Of course, I wouldn't doubt it in the least. So, no, Robert, I'd love to hear your thoughts about checking. It's like, how do you? I guess, Robert, my question is like, what would you tell teachers who ask you with the open middle, like, my students have such quick access to calculators, like even the thing that I just did doesn't necessarily take that ability away. I can't force them not to use it. Are there any strategies or what could you tell teachers? Like, how could we address these issues of when I really want to focus on the conceptual and less of the just get the answer? Because technology, you know what I mean?
Yeah, I think kind of maybe centering, I think one of the centering questions is like, what's the goal, right? Like, what are you actually getting to? And I think that oftentimes it's helping them realize that a lot of the procedural, like you could be amazing at addition and subtraction, but if you don't have conceptual understanding about like which digits would be better to start with, you could be guessing and checking for a very, very long time.
Right.
And so then what I think is important to realize then is that what's the least helpful, like Dan Meyer talks about in his TED Talk, what's the least helpful you can be? The metaphor I use often is that of a bench presser and a spotter. If the students are the bench pressers, we are spotters, right? We want to give them enough help so it doesn't crush them, but not so much that we lift the weight and we're the ones to get stronger. I find that there's potential that if you have like a check button, it has the potential to make checking the calculation so easy that guess and check is actually not a bad strategy. Sometimes I want them to feel the pain, like, oh my God, it takes forever to check this. There's got to be a better way to do it. And then conceptual understanding becomes the aspirin to that headache. So there's definitely, in some situations, great value to it. But I think sometimes, like Dan says, like we want to be less helpful. And so just being really clear about what your goal is important.
Right. No, I love the analogy there. It's very, very, that's really good thinking. The spotter and the bencher, the person lifting weights. Alice, do we have any questions coming in the chat? Any other things that we want to talk break before moving on, or?
We got Melody joining us, so shout out.
Hey, Melody.
Hi, Melody.
Hey.
No, Melanie.
We do have a question from Melody. I think she said, are calculators bad to use? I feel like calculators help us keep our sanity if there's any to be found. What's the wisdom on that? Because I've got opinions.
I am not anti-calculator. In fact, in some situations, I think like it's ridiculous. Like say to make kids find sales tax and make them actually multiply it out. Like that's ridiculous. Everyone uses calculators in real life. So what the hell is the problem here? What I'm saying is that when the actual goal is to teach the procedure and the conceptual understanding, at that point, it may not be useful. But I want to stay on the other side of making a blanket rule of this is always good or this is always bad. But in general, I would say that when the goal is to better understand the concept, maybe don't use the calculator. But when the goal is to apply it, and it's even if it's inhibiting you from learning that next topic because they have to do the brute calculations, then if you would use it in real life, then let them use a calculator. There's no harm.
Yeah.
Right.
Yeah. And Melody,
what were you gonna say?
No, I've tried with like even with a typical, like when I was teaching full-time high school, it's like I tried to address that issue where it's like if I have an hour with the kids and it's a full hour for the test on quadratics, say, I might give them one page to start with. Everybody sits where they go, calculate away. There's 2 questions. Maybe like graph this parabola, and it's like simple, like nice coefficients, like nothing about to trick you, whatever that. And then maybe here, solve this quadratic any way you want by hands. But after that, you know what? The next problem, number 3, hey, target sales in millions of dollars is given by the function. Now I need the tech to actually do the analyzing that someone up in the upper management would do. you know? But trying to make every single test have one page, no calculator, you hand it in after 10 minutes, then the rest of it, here you go. That kind of worked for me in a sense. I'm sure there's other ways, but you're right, Robert. I agree. There's not like an all or nothing kind of a thing, you know?
Yeah. I use the calculator as the machine, but our greatest machine is up here, right? It's our brains. And my wife is an adult learner. She's in nursing school right now, and her professor had a complete meltdown, in a math class. And it was also a nutrition class the other day, because people are Googling answers and like, I can't believe people are using a calculator. If the answers can be easily solved with the calculator, is that really the best question you should be asking your students? Because at that point, it's application and it's not critical thinking, right? So I always think about it in the realm of that. Are we asking critical thinking? Are we asking for application? It's not that application is bad, but if all of the questions that you have your students do can be easily answered by typing numbers in, you just might want to think a little bit more about what the critical thinking is on the back end. Because we want them to be able to explain, right? We want them to be able to learn. We want them to be able to apply. Melody, I agree. I want my nurse to use a calculator too, for sure. But part of that is, the explanation. Can you actually explain the math that's going on? And sometimes that's lost when you use a calculator. So I definitely see both sides, and I agree with both sides. Why not merge them and make them a beautiful collaboration instead of having it being 50-50?
Yeah, I'd like to just talk about the idea of fluency a bit too. I think what Robert points to when he's talking about his goals for open middle problems is really that concept of being fluent with mathematics. That means also that sort of the fluid use of math, fluid use of numbers and operations and the relationships between them. And that's achieved sometimes with a calculator and sometimes without. I think you need both of those experiences. And these open middle problems are really great contexts for thinking through and helping students gain that fluency, become genuinely erudite in mathematics, even, so that they can use all of the tools available to them. So
I agree with you. In fact, Chris, the next one we were going to show, I think, literally is an exact illustration of what you just said. That like through the conceptual, they build a fluency. I'll show you right here. Let me just. But it was the one. It's on Open Middle site. It's under grade 2, I think. But it's sorry, I lost it again. Open Middle. There it is. So it's actually the one where they have Robert. I don't know if you remember this one, but the one where they have 12 squares. And there it is, right there. It's an open middle problem from Brian Anderson. Using the 12 squares, how many different rectangles can you make, right? And just nothing fancy. So here it is, right? We can go here. We could see the formations that kids are building. But again, they're going to start developing fluency with this because they'll start saying, "Oh my gosh, 4x3," and they'll even discover like the commutativity, like multiplication. Like, wow, a 4x3 rectangle, I guess, is identical to a 3x4, or whatnot. But then imagine you as a teacher giving your second graders this, say, and students can just go ahead and comment away digitally. I mean, but why not? And then as a class, you can make some cool, again, they can develop that procedural quickness. A 3x4 is 12, but through this open middle, open-ended context, I guess, if that makes sense. Yeah. But let's see. We're oh man, I keep losing it. Sorry. But let's actually we'll look at one with the actual. I googled aquafigure, but we can go to the. Whoops. My bad. So we go back into open middle here, and I think it was in the geometry K through 6. There's a bunch of them, but like we can have even ones like right here. There was one from was it this one? I think it was this one here. This one was a problem from Patrick McGowan. I think, Robert, it might have been grade 6. I'm not quite sure. But basically, the perimeter of this was 46. You have a trapezoid here whose perimeter is 46. And the goal here is to find the trapezoid with that fixed perimeter. See, everywhere I move this trapezoid, the perimeter is always going to be 46, right? But the goal is to get the trapezoid that has the greatest area.
And I think that this is along the lines of what I love the most about GeoGebra in terms of a partnership with Open Middle, is this idea that you can visualize stuff, and what does that mean, and how is it possible that there are multiple trapezoids at the same perimeter, and how is it possible they don't have the same area too, and why is that? And so I think there's a lot of benefit to these visualizations and the conversations that they lead to.
I wholeheartedly agree. And even like said, this is a problem that they often ask in calculus, where they have to like literally write the function and they have to take the derivatives. But it's like, it's an optimization question. But we're asking sixth graders to do this, which I think is so like, I think that's awesome, you know? But again, the possibilities, like the people's creativity I see on the site are just so in my opinion, they're just so cool. And this one here is with this problem, if you wanted to as a teacher, you can create different analogs. What happens if we fix the perimeter at 38? You know, what's the greatest trapezoid that we can build here? You know, or whatever. But pick your perimeter. I think it's like 3 to maybe 100 or something like that. But the point is, they're all gonna, these 2 points are movable, and you can create a GeoGebra class from that and literally watch what the kids are doing and then analyze results, do whatever. But let's go up the grades a little bit here, if we may. I think it was this one. This one was from that one. Hang on a second. Let me just zoom out. Where was it? Right. I think it was this one. Now, the original app was made at IM 6 to 18. See, like IM 6-day curriculum, right? They actually have a lot of GeoGebra in there. But right here, the goal, I think the open middle problem said it was an open middle problem from Dr. Brian Lack. Here we have 27 identical cubes that make up this big cube, right? Now the goal of it is to take cubes out of here by moving the white points, so that we create so that the remaining surface has the greatest possible surface area. Now that one's a beast, right? And if you want, let's actually create a class from this. Like, we can't pass out cubes at home, but we can actually do virtual cubes right here. We'll just do this one more time. We'll create a class. Open middle. And even if you're watching this, like say days after this broadcast, I won't delete it. You can join it at any time. Take 2. Here we go. And I'll give you guys the link so you can join. I'll copy the link right there, and we'll throw it in there. Okay. Link to 3D class. Come and build virtually. All right. Let's give this a shot. Let's see. There we go. So we have students coming in now. They're again, internet speeds are very finicky. You know, there's some times where, you know, there is just always a day every 2 months where Google's just down. It just happens, right? It could happen with GeoGebra too. Doesn't happen often, but basically it, you know, once every 4 or 5 months, you might find something. Hey, it's taking forever to load. Nothing in tech is perfect, as we all know. And the fact that this is 3D might slow it down just a tiny bit, but that's okay. All right, but let's see what you guys are doing here. All right, we'll just stick to task 1 there. Again, I'm seeing everybody here, right? Just trying to make it, and just get used to like working in 3D. Like, what the heck am I doing? All right. Looks like Robert's upside down. And he's just there. But see, if you just do it all there again, but who am I to say what's upside down? You know, it's that you look at whatever you want in here. But I will show you, for those of you that might have a hard time with 3D, I'll show you how the way to work it is really simple. If this is your first time looking at it here. So the way it works is that the white points move the cubes. See, here I'm moving it on the same level above that grid. It's like 1 or 2 notches above the grid or something. But if you click on your mouse, if you just keep clicking on that point, you see how it looks like north, south, east, west. If you click it again, you have the up, down thing. So you can move this thing up above the grid, and you can move it below the grid, like so. So don't feel like as a teacher you have to know how to do everything in the tech perfectly before you give it to your students. You will learn from your students. I learned so much tech for my students when I started dabbling with GeoGebra the first time, and I found out things I was taking forever to do, and they just did with a click of a mouse, you know? And I think that speaks a lot to students that we can actually learn from them. You know, I think that's is really powerful.
I think it's important. I mean, sometimes even if I do know it, I'll act like I don't, you know, and so I can credit the kids. A great way to bring them in.
Mm-hmm. Right. But this question is something that's like is a beast, because it's like, think of all the possible combinations of cubes you can remove and or keep in. You know what I mean? It's like if I take all the cubes out and leave the center there, well, that's a surface area of 6, right? The one like in the middle. But how many do I take out? You know, here, you know, and I know the solution is an open middle site there, but it's really kind of cool. It gets the kids to reason, like, oh, if I take out 1 cube, the surface area goes down by 1, but then I added I added 5 more by taking out the. I mean, so, but yeah, but see, this is the fun that you can have with your students remotely, and the answer is not so immediately obvious. It's not something that you. Yeah,
I think this is a really great example of where there's a synergy here, because this is not necessarily, you know, kind of building off what Victoria said, like it's helping people do the parts that are not necessarily the end game, but really help you get to the meat of the math here, right? So you're, and I mean, let's be real. This is actually, dare I say, better than it would be in person, because how can you possibly see where every kid is at and let every single kid have authentic access to all these manipulatives at the same time? I really think you get to spend more time on the things that matter and less time on, like, I mean, can you just imagine distributing these cubes in class? Like,
yeah, I was going to say that. I just feel like this would be a disaster to deploy. You know, if any of y'all are face to face, my district is still 100% remote, but all the different cubes, right? How do we make a cube? What does it look like? And that tactical element is really important for kids, especially our younger learners. But I mean, it's just so simple, right? And we have the tactical element with all of the different, you know, things that we can do in GeoGebra. It's just easier to deploy, and I think easier to find solutions. That way we can get to the discussion, right? We can get to the critical thinking, and we can get to the analysis.
Yeah, those comments are really fun to hear. They're really awesome to hear, because honestly, I've done stuff like this with my kids in my full-time teaching, and like I have gotten dirty looks from the janitorial staff. Like at the end of the day, I was like, oh yeah, I'll get those later. They all on the floor, you know.
I've been there. Yep.
Yeah.
The maker space, they can get some kids glued items together.
Totally. But yeah, this is like fun stuff you can do. And again, any one of these open texts you find in GeoGebra, you can create a class from and engage your students in real time. Is really, like, you know, the main idea. GeoGebra provides the technical piece. Open Middle provides the very powerful pedagogical improvement, that piece. The two together, again, the way I see it, I see it as a beautiful integration. And which is why I've been promoting the heck out of it lately, because it's just like there's just so much you could do with it, and you can't easily Google it. You know, it's like, but and Robert, I have to ask, Robert, have you ever had teachers work with students and find that they find Open Middle site and they find the answer down there, and the teacher's like, has that ever been like an issue at all? Because you have a sample solution, even though there's many. I'm just curious.
I'm sure. I mean, what's interesting, actually, on a really weird note, is that like when the pandemic first began, I think teachers sent their kids to the site not fully understanding that wasn't the purpose, and so the kids would just be adding their own answers in the comments. I don't totally get it, but I would say that in general, I mean, there's legit have been times where like people who are students in class find answers that are better than the answers I came up with, because I didn't know that there were better answers. And then you see like a comment like, my 5th graders found a better answer than what you wrote. And then I put it on there. And now really what I'm doing is outsourcing my work to children. But what winds up happening is that the kids are like, I mean, math is no longer like something invented by like old white guys 400 years ago, 1,000 years ago. It's something they can actively participate in creating. And then when they see that their answer is now the new answer, there's some value there too. But yeah, I think that a lot of children really just love the process of really, which kids don't want to play around with that, right? Even if they could see the answer, why is that the answer? I think there's something about the way these problems are that makes you want to participate, and the answer is no longer the most important thing.
Right. That's cool. It's funny. Just outsourcing your work to the students. That's pretty funny. It's like, and you find something like, hey, yeah, and you feel people. It's like, that's my thing of the day. Hey, Robert, I found something better. It's like, okay, great. It's like,
there are a lot of those.
Yeah, and even with this open middle thing too, ladies and gentlemen, there's a lot of quick like class openers. Like some open middle problems you might not want to have take like the whole class. I want it to be like my bell ringer, my do now, whatever you call it, anticipatory set. Okay, you can actually. I want to feature this. I want to show off this one that John Albright created. John lives in Indiana, and his GeoGebra skills are far, far, far beyond mine. I will tell you that. He's in the same class as Steve Phelps. Those guys are like way, way up there. But I think in this one, or maybe it was in the, I think it was in this one here. It was making a linear function. I think it might be in this chapter here. But I love showing this one here. Give me a second. Actually, I have the link right here. Hold on. It's in the book somewhere. I just don't know where it is. But trust me, it is. Here it is. Okay. So again, we won't make a class out of it. But again, imagine making a class and asking your kids to just make a linear function.
It's cool.
Like, yeah, so 2, 4, 6, 1, what it means to be linear. Now, John programmed it so that it just spits back linear or not linear. You know, we could check it here. And see there?
That's cool.
It is cool, right? But obviously, it's like, you know,
animation.
Yeah, I love his animated work. It's just John's just an amazing GeoGebra genius. But even here, you know, we can actually, you know, JC and predict, and even if it's not, we can just 2, 5, 5 and 3 is 8, and say 3, 6, 9, right? And just kind of 3, 6, 7. Sorry, let's get it wrong and see what happens.
And what I think is, I mean, also we're just considering is that you can quickly differentiate and modify a problem in real time. Like, right. Okay, so someone found one that's linear. Like, what's the steepest linear function you can create, or the least steep? Or can you make one that's not, that has no slope, or one that's vertical? Like, and just kind of unpack what is possible and what's not.
Right.
Make one that has a negative slope. Like, what are the possibilities here? I think that there's a lot of really fast differentiation you could do that's not just like, and now do 50 more. It's meaningful.
Totally. Totally. And again, if you missed the first part of the broadcast here, you can always go back and rewind. But again, what Robert just said, differentiate, I'm telling you, clicking on this right here is literally a 5-minute, it's a 5-minute differentiating act. Like literally, I could ask them what Robert said, make the steepest slope. I copy it. John, it still credits John for creating it, but now I have my own version of it, which is beautiful, you know? Yeah. So other things too, even let's move up the grades a little bit to like say high school, middle school, high school geometry, even still in the book. This was one that I found maybe it was Robert. I think there was one on GeoGebra on Open Middle site that had it like fixed at a certain point and you had to make a parallelogram. But basically the problem here is that we have to now to build a parallelogram, making sure that no coordinates repeat. Okay, so obviously teachers would think, you know, students want to just do something like this. But obviously, if the line is if segment's horizontal, you're going to have the repeated coordinate, right? It's the y coordinate there, and you know, kind of like this. But can we do this now so that no coordinate repeats? Again, this is a lot harder than it looks, because yes, we can build a parallelogram and conceptually, we need the same slope here. That's 4/2, 4/2. The reasoning here, but oh crap, some coordinates repeat. Now, Robert, how many times, Robert, have you actually had teachers like kind of like ask you the significance again, but like, why do you force them to make coordinates not repeat? Is it just to kind of like be the spotter that pushes down on the rates, or like how do you answer that question? I've always been meaning to ask you, but not to do it publicly, but go ahead. Yeah,
I mean, I guess the question is like, can we go back to this a really basic question? Like, if you had blank blank plus blank blank, a second grade problem to make the greatest sum possible.
Yeah.
And you said use any numbers. Well, that's kind of trivial at this point, right? It's just you put 9. If you said make the least, you put 1s. But if you make a restriction that's not necessarily arbitrary, and you say, 1 through 9, you'll see situations where kids will do 9, 8 plus 7, 6. That's not bad, right? Those are the 4 greatest digits to use, but that's actually not the maximum value it could be, right? Because you want to have more 10s than 1s. And so restrictions that are well thought out are not necessarily just like random, like make a shape that looks pretty. Like it's something that is going to help them try to be more efficient, or maybe think of a connection that maybe they wouldn't make otherwise.
Gotcha. No, thanks for that answer. I've been meaning to ask you that this whole time, but yeah, no, that's pretty powerful. And so even right here, the fact that in this app, you actually cannot go beyond 9 because the directions say in GeoGebra it's possible to make it be where you want. It's got to be between 0 and 9. But again, it is possible. I don't have the quick solution right. I don't have a quick solution right here right now. But the thing is, let's suppose this was a okay answer, but how would I have students justify? That's where the GeoGebra part comes in. Like, what does it mean to be a parallelogram? We could take the slope and just touch on the segment itself. Oh, that slope is, again, that's the numerical approximate for 1/3, right? But even here, 1/3, and what's this one? The 1.5? 1.5. And teachers ask me, how do you get the fractions out? I'm like, well, why do you want, why is having the fraction, the exact expression of the slope, why is that necessary? I mean, isn't it more important? I guess my opinion is that the slopes of these opposite sides are the same, right? And so are here. So therefore, that justifies the fact that it is a parallelogram. We can answer that in the question.
I think that's something that we should be aware of all the time, is representing things the same way that we've always done. If we always represent it as a fraction, if we always represent it a certain way, that in itself is a problem.
Right.
Remember, I was at a presentation one time, and this guy was showing how if we put 5 = 1 + 4, you feel weird. That shouldn't feel weird. And yes, just always do it the other way.
Right.
Absolutely.
Right.
Yeah. So, I mean, here it's like, now I don't think it's on Open Middle site, but you know what, as a teacher, I'm thinking, wait a minute, if I could ask my geometry kids this about a parallelogram, why not, when we talk about special parallelograms, why not just ask them to do the same thing? Actually, to make this one, I didn't have to do the work again. All I did is I copied my own activity, and I changed the word parallelogram to rectangle. See what I mean? And then I copied this one, and I changed that word rectangle to rhombus. You see what I'm saying? So it's kind of like I could literally like just try to have my kids build a rhombus. Now this is harder, and there's a lot less options, solutions, I should say, but it's still thematic of the open middle philosophy. You know, and I would venture to say that if I, teaching geometry remotely is very challenging, very challenging. So it's like, instead of asking kids just to do what photo math and, typing in a cell phone calculator can do, we can give them something where they actually have to build, create DOK 2-3. And why don't we let, say, this problem serve as a quiz grade? Even though they have tools, they can look up something in notebooks, who cares, right? But could we actually use this to summatively assess our students, to put some number down that administration wants us to put down? I don't know. What are your thoughts?
I mean, I think to some degree, the thing that math education doesn't want to really think about or say out loud is that the vast majority of what we teach, no one ever uses in their life.
I know.
And at the same time, there's so much freaking math you actually totally need that we don't teach.
Yep.
And
let's say the quiet part out loud, right?
Yes.
And so the conversation we need to have is like, are we doing this way because that's the way we've always done it, or is that because it's the best way to teach it? And there's a lot of that status quo bias here. So I think anytime we can shift to start teaching more of the problem solving or the thinking about, like kind of going back to again what Victoria said, like if we're spending more time thinking about what we put in the calculator and less on actually the calculations, I think there's value to that. A lot of the easy problems in life have already been solved. What's left is really challenging stuff. Right. So I think that open middle problems and even in partnership with GeoGebra allows students to focus on the kinds of habits of mind that will really carry with them into whatever comes next.
That's cool.
Absolutely.
That's cool. Now, Alice, we're with the whole, isn't that what, because I've been doing a little bit of reading, I know all the time, but like with Joe Bowler, that's what she's like pushing for with the
high ceiling.
Yeah.
Yes.
And honestly, just to show you, even because some people, when they and GeoGebra has helped people go to GeoGebra sometimes, they get so confused because it's like they say, Tim, there's so many freaking apps. Which one do I use? I'm confused. And I understand people. I understand you go there. It can look very intimidating, and you're stressed out remotely for teaching. It's like you're not sure. Like there's some parts that are easy, some parts is a steeper learning curve. But just to show you what you know, what Robert and Alice were talking about here, really quick before we close. When you go to GeoGebra's main site, right here, you go to geogebra.org, right? You see all these apps here. You see Calculator Suite, 3D Calculator, CAS. I mean, I asked teachers, well, see a computer algebra system, right? That literally will solve equations for you, which is like literally forbidden by so many state departments of ed here in the United States. But when you go to, if you go to Europe, where GeoGebra is based out of Austria, they're in Europe, right? But if you were to just basically type in, you know, solve 3x minus 2 equals, say, 4x, see how it's right there, say 3x minus 2 equals 4x squared plus 2x minus 1. I guess that's not the, let me just try right here. See, like it does it for you. Now in Europe, this is allowed on all examinations because Europe doesn't like actually focus on the actual procedural mechanics there on a lot of their high stakes exams, right? But in order to comply with you know, a lot of for districts in the United States, that's why GeoGebra took a lot of that functionality out of the graphing calculator. So if you're looking for a calculator where you can't have all that fancy stuff and all that computer algebra solve in there, this one has, I can't even find the midpoint of anything in here because it's that tool was taken out of here. Any geometric construction features, any CAS, see, it tells me it can't do it. And so therefore the US district happy, but at the same time they could do what they do for those in Europe. But again, I don't want to get too, yeah. Sorry, I can't see you guys. Were you saying something, Chris?
I think Robert was.
Oh, Robert was. I'm sorry. Go ahead, Robert.
No. Okay.
Okay. Sorry, but yeah. So open middle. Yeah. Anything else? I mean, I know there are more, but I think it's about time. It's natural feeling to start closing up shop here. But yeah. Any comments, questions? Feel free to type away.
I just think this is so cool to have that applicable math in a virtual setting. And we'd use GeoGebra at my school site. So we did something similar to the last activity you showed, where we actually created rooms, you know, based off of, you know, squares, parallelograms, rectangles, you know, all these different things. But then what we had them do was figure out if the house were to shift, right? Then what would happen if it's like a transformation or reflection, blah, blah, blah. Because originally when I was working with folks, you know, they said, okay, well, it's left, right? Like that's a shift, that's a transformation. But I was working with high school teachers. So, you know, that might be something I would expect from lower grade levels. But at high school, middle school, we got to get more specific with the coordinates, right? We need to understand exactly what the shifts look like. They couldn't conceptualize it when folks were just doing it on the board. But when it came into GeoGebra, that's when it really came to light. So I'm really excited. I didn't know about, you know, the open middle merger or, you know, collaboration, but I'm so pumped to check this out and share it with my teachers because, I mean, that's a complaint that we've been having where they're just not engaged with the math as much as they would in a face-to-face setting. This gives opportunities for asynchronous work. You know, it gives opportunities for, you know, if you were presenting in a, you know, virtual environment right now, synchronously via Zoom or Google Meet or what have you. Like, it's just so cool. And I'm really excited to share this with my teachers.
That's awesome. That's great to hear.
Yeah.
And I can't, I mean, like, I wish I knew of Open Middle. When was it founded, Robert? Was it 2015 before? Like, when did you?
Probably like 2015, 16, somewhere in that range. I don't remember now.
Okay.
But I guess what I would say is, I mean, with open middle problems, they don't feel like busy work. Kids love doing them. They can replace the entire
interactive. Like, it is so interactive. It does not feel like busy work at all.
Right.
It can replace an entire worksheet, and it helps build conceptual understanding. They lead to great conversations instead of like when you have kids in groups, they're just kind of like, you do the odds, you do the evens. No, the kids love talking about it, and they can really help you spot hidden misconceptions. So if you're interested in learning more about Open Middle, I think a great place to start, like Tim said, everything on Open Middle is free. But if you go to openmiddle.com, there's a picture of kids working. And in the middle of that, we've put a download where you can get our favorite problem from every grade level, from kindergarten through calculus. So if you're not really sure where to begin, you can download that, and then it'll give you kind of an idea of what this is like and really where you can go from that. And then when you have that, then you kind of have an idea of what maybe is available on GeoGebra.
Cool.
Nice.
Yeah. So Yeah, with GeoGebra, we'll keep adding it. I know Steve Phelps likes to create them. John Albright too. I know I like to create them maybe 1 or 2 a week, but whenever time permits. But yeah, So no, thanks Robert and Victoria, Chris, Alice for doing all this and fun. Yeah,
Thanks for letting us play.
Thanks for the invite.
Yeah.
time.
But again,
So,
put all your
right.
work into GeoGebra, Tim. That was awesome. Thanks, Robert, for coming.
Thanks. Have a great day, everybody.
Guys.
Bye, everyone.
Bye.